Hello, fifth graders, it's Mrs. Tremblay. Today is Wednesday, February 24th, and we're gonna check our bell work. So hopefully you have this all done. You're just checking your work with me right now. And let's get to it. For problem number 1, it's 3/4 minus 1/6. Because this is a subtraction, you need to have a common denominator. When I look at this 4, I see I can't multiply 4 by anything to get 6. And I am quite certain that a lot of you at this point went 6 over 6, 4 over 4. You multiplied it by that. You could actually use the LCM of 12 because the first number that 4 and 6 would have in common if I counted by them is 12, not 24. If you didn't see 12, it's okay. You're gonna get the same answer as me at the end. So I'm gonna go ahead and I'm gonna multiply 3/4 by 3 over 3 and 1/6 by 2 over 2. And if you did 6 over 6, 4 over 4, you're fine. You don't need to change your work at all. You'll get the same answer as me at the end. So this would become 9/12 minus 2/12. And 9/12 minus 2/12 would give me 7/12 because 9 minus 2 is 7, and then you keep the 12 the same. Now if you use 24, you probably have 14 24ths, right? So if you have 14 24ths, both of those can be divided by 2, and 14 divided by 2 is 7, and 24 divided by 2 is 12, so it'll simplify down to the same exact thing. All right, number 2, this is also subtraction, and I need a common denominator. I can't multiply 9 by anything to get 10, and 90 is the first number they have in common if you counted by them. So I'm gonna multiply each fraction by the opposite fraction's denominator. That would mean 2/9 needs to be multiplied by 10/10, and 1/10 needs to be multiplied by 9/9. So now we have 20/90 minus 9/90, and 20 minus 9 is 11, and what it's out of doesn't change, so 11/90 for number 2. Number 3, again, it's subtraction. 7/8 minus 1/4. I need a common denominator for this one, and I look, and I can multiply 4 by something to get 8. I can multiply 4 by 2. So I'm gonna multiply 1/4 by 2 2s, by 2 over 2. So I have 7/8 minus 1 times 2 is 2, and 4 times 2 is 8. Now, 7 minus 2, that's 5. And I don't do anything to the 8 because the 8 tells me what the whole is broken up into. So leave it alone, 5/8. Right, now we are into some multiplication. And I see I have a fraction multiplied by a mixed number. So I know that fraction stays the same. And this I want to change to an improper fraction. So 3 times 3 is 9, plus 1 is 10/3. So we don't have to have a common denominator when we're multiplying fractions, right? They just both need to be in fractional form. Okay, I'm going to look to see if I can cross simplify anywhere, and it looks like the 8 and the 10, those are both even. So I could go ahead and divide 2 into both of those. If you didn't, don't worry, you'll get your same answer as me at the end. So 2 goes into 8 4 times, and 2 goes into 10 5 times. 5 times 5 is 25, and 4 times 3 is 12. Now I know that 12 goes into 25. 2 12s makes 24, and 24 plus 1 is 25. So you should have 2 and 1 12. If you had 50 over 24, then 50 over 24, 2 24s would go into 50, and 24 and 24 make 48, right? So 48 plus 2 is 50. So, sorry, I just said 50 and wrote 50. So if you got 2 and 2 24ths, you're on the right track, but aren't 2 and 24 both even? Yeah, so you could divide them both by 2 to get 2 and 1 12. So if you had this to start, you have an equivalent answer, but you can go one step further and simplify that. All right, for number 4, 4 and 3/5 times 5, I'm gonna go ahead and change this to improper. 5 times 4 is 20, plus 3 is 23/5 times, and when you multiply by a whole number, you just put a 1 underneath it because 5 divided by 1 is 5. Those are equivalent. I look and I see that I have 2 5s diagonal from one another, and 5 goes into itself 1 time. So we're left with 23 times 1, which is 23, and 1 times 1, which is 1, and you just get a plain old 23. You could have multiplied the 23 by 5 and then divided that by 5, and you would get 23 in the end. But if you can cross simplify beforehand and just take some of those extra steps out. All right, so I'm multiplying 2 mixed numbers. Let's go ahead and change them to improper fractions. 5 times 1 is 5, plus 4 is 9/5 times 9 times 3 is 27, and 27 plus 4 is 31 ninths. All right. So now I see that there are 2 9s diagonal from one another. That means that 9 goes into 9 one time. Did you think you were going to have to do 9 times 31? I know, you don't have to. If you did, you're probably like, oh man, I didn't see that. Anyhow, 1 times 31 is 31, and 5 times 1 is 5. So I have an improper fraction. I know that 5 times 6 is 30. That's going to get me closest to 31. And it takes 1 to get from 30 to 31. That's my leftover numerator out of 5. And if you want to double check, remember you could always do 5 times 6 plus 1. Oop, 31 fifths. We know that we're right. Okay, now I have a couple division problems here for you. The first one is 3 divided by 8. So this is like those waffle examples. If you have 3 waffles, you don't have to draw this. I just feel like I need to. If you have 3 waffles and we're gonna share them between 8 people, that means that each one of these waffles will get cut up into 8 pieces, right? Sorry, you know I have to hit the camera. I do it every single day. So each of these waffles will be cut up into 8 pieces. And if I'm sharing between 8 people, that would mean each person would get 1/8 of this, 1/8 of this, 1/8 of this. So 3 divided by 8 is the same thing as having 1/8 3 times. So you should have written 3 times 1/8. And if you have 1/8 plus 1/8 plus 1/8, you do have 3/8. And it makes sense because aren't fractions division problems? They are. And this is 3 divided by 8, which is exactly what that says. All right, if you have 14 divided by 3, that would mean you'd have 14 waffles, and each one would be cut up into 3 pieces, and each person would get 1/3 of each waffle. So that means that you would have 1/3 14 times. 14 times 1/3 is the same thing as 14 divided by 3. So if you have 1/3, 1/3, 1/3, 14 times, then you would have 14 thirds. And if you saw this as 14 over 1 times 1 over 3, and you got your 14 thirds, you're not wrong, right? See, it's the same thing, except this is improper, so let's fix it up. So 3 times 4 gets me closest to 14. 3 times 4 is 12, and to get from 12 to 14, there's 2 left out of 3. So 4 2/3 is what you should have. Okay, now we have dividing a whole number by a unit fraction. So this is asking you how many 1/5 there are in 7. Well, how many 1/5 are there in 1? If you took 1 and I want to know how many 1/5 are in there, wouldn't you divide this up into 5 pieces? And how many 1/5 are in 1? 1, 2, 3, 4, 5, right? So if one whole has 5/5 in it, okay, then how many would 7 have? Wouldn't we have 5 7 times, or 7 times 5? So there are 35 1/5 in 7. 7 divided by 1/5 is the same as 7 times 5. For this one here, 12 divided by 1/3, I'm asking you, how many 1/3 are there in 12? Well, there are 3 1/3 in 1. So in order to figure out how many are in 12, I can just do 12 times 3. So 12 times 3 is the same thing as 12 divided by 1/3, and it's 36. It would be really cool if this one's 37, but looking at those numbers, I'm guessing it's not. All right, I want to know how many 11ths there are in 9. Well, in one whole, there would be 11 of them, right? 11 11ths. And in 9, then, there would have to be 9 times 11. So 99 would be our answer for that one. And you're all set with your bell work for today. See you soon.